Welcome. In this video, we are going to take a look at problem 7. It is from chapter 22 of College Physics 2E by OpenStax. We need to find the maximum magnitude of force on an aluminum rod. We know how much charge it has. We know the magnetic field it passes through, and we know its speed. And we also need to tell the direction of the force. Okay, let's start with what we know. We know the charge Q is 0.100 microcoulombs. That will need to be converted. All right, we know the magnitude of the magnetic field is 1.50 Teslas. We know the speed is 5.00 meters per second. We are looking for maximum force, so that means the angle between the velocity and the magnetic field is 90 degrees. Okay, our starting equation is F is equal to QVB sine theta. So we have everything. We can find the force. Okay, charge is 0.100. Micro means times 10 to the minus 6, and that's coulombs. Velocity is 5.00 meters per second. Magnetic field, 1.50 Teslas. And then we need the sine of 90. Sine of 90 gives them the maximum. So that's going to be our maximum force. Okay, I did this calculation. I got 7.50 times 10 to the minus 7 newtons. That's the magnitude of the force. All we can say for the direction is that the force is perpendicular to both the velocity vector and the magnetic field vector. We don't have their directions, so that is the best we can say. So we can say F is perpendicular to both velocity vector and magnetic field vector. Okay, that's going to do it for that problem. I hope you found that helpful. Let me know in the comment section if you have any questions or if there are other problems you'd like to see me solve. Thank you for watching. Please like and subscribe, and I will see you in the next one.